Assalamualaikum warahmatullahi wabarakatuh. This is a presentation for subject Civil Engineering Materials ECS246 with the topic Innovation in Advanced Material prepared by Zikri Iqbal, Ahmad Hafiz, Yamin Bukhari and Aiman Haziq. There are five main contents in our slide presentation. Firstly, we have introduction. Secondly, methodology. Thirdly, we present our findings. Fourthly, our discussion. And last but not least, we present our conclusions in this slide presentation. We move on to our introduction. Self-healing concrete, SHC, a well-established and well-known characteristic of concrete because of its natural capacity for self-healing. Fissures can heal because of the continuous hydration of clinker minerals or the carbonation of calcium hydroxide. In 2006, self-healing concrete was invented by the microbiologist Professor Henk Jonkers at Delft University of Technology, Netherlands, as a new type of concrete. After 36 months of testing, he found the perfect healing agent, which is bacillus. Bacillus species can be either obligate aerobes, which are dependent on oxygen, or facultative anaerobes, which can survive in the absence of oxygen. According to the findings, Bacillus bacteria greatly enhance the compressive strength and speed up the healing process in cracked cement concrete mixture. If the bacteria meet oxygen and water, they will convert nutrients to calcium carbonate, which is limestone. This means that the cracks will fill up and the concrete remains waterproof. This process can repeat itself again and again. There is no need for manual maintenance or crack repair works. There are two methods of application of self-healing concrete. Firstly is direct mixing. Secondly is encapsulated in lightweight concrete. We move on to the apparatus for preparing bacteria. For direct, we have bacillus cell and fresh water. For encapsulated, we need encapsulated particles contain bacillus pseudophilus and encapsulated particles contain calcium acetate, yeast extract and dextrose. And next is apparatus for compression test, which is we need only compression test machine, and then concrete casting, which is the mold for cube size 150 mm, electrical vibrator, trowel and scoop, tools to assemble the mold, brush and grease, concrete mixer and curing tank. Next is procedure for preparing bacteria for direct method. First, mix the bacillus with water to make bacterial solution. Weight the concrete material with bacterial solution. Wipe pan concrete to avoid the material sticking to interior surface. Fill the mixer with the material. Blend 1 to 2 minutes. 6. Turn off mixer and move concrete to the table with vibrations next to the mold. Add layers to the cube mold that are 50 millimeter deep. Each layer you should use vibration to compact the solution. Use trowel to create a level with the top of the mold. Demold the specimen after 24 hours plus 30 minutes being kept in damp air. Lastly, always letting the specimens dry before any testing. Next, we move on to procedure for preparing bacteria in encapsulating method. Immobilize the spores of bacillus in separate EP particles while nutrients were encapsulated in separate EP particle. Once impregnated, spores and nutrients coated the expanded perlite to block the leakage. Self-healing process was more pronounced with 20% EP as aggregate replacement. Weight the concrete material with encapsulated bacteria. Wipe the concrete mixer pan. Fill and blend the material for 1 to 2 minutes. Turn off turn off the mixer and move to vibration table. Next, add layers to the cube mold that are 50 millimeter deep. Each layer should use vibration to compact the solution. Next, use trowel to create a level with the top of the mold. Then demold the specimen after 24 hours plus 30 minutes being kept in damp air. Lastly, always let the specimen dry before any testing. Next, we move on to procedure for compression tests of concrete. Firstly, remove the test cube from the curing tank and clean them until they are moist and dry. Second, clean cube surface from any debris. Thirdly, measure specimen's measurement or dimension and weight the sample. 4. Insert cube in the test machine. Make sure the surface of testing device are clean. 5. Center the cube and apply load gently on the specimen. 6. Track the maximum load. And 7. Record the type of failure occurred on the specimen. Next, we move on to our results. Sample number 1, which is tested on day 7. For normal concrete, we obtain 20.85 megapascal for compressive strength. For bacterial concrete, we obtain 27.10 megapascal for compressive strength. And sample number 2, we tested on day 28. For normal concrete, we obtain the compressive strength of 30.0 megapascal. As for concrete, bacterial concrete, we obtain 38.95 megapascal in compressive strength for day 28. We move on to the analysis of our test. Um, First, we can see compressive strength comparison after 7 days, which results in bacterial concrete has higher early concrete strength than normal concrete. And then we move on to the compressive strength comparison between bacterial and normal concrete after 28 days. Results in bacterial concrete also have higher concrete strength than normal concrete because of the self-healing characteristics uh, present in the bacterial concrete. Next, we move on to the benefits of self-healing concrete. Firstly, towards economy, self-healing concrete for cost is not economic. It needs big amount of money to manufacture the self-healing concrete, but in the end, it saves costs in long-term maintenance. Next is benefits of self-healing concrete towards community. Self-healing concrete is, of course, harmless to human life. Next is we can ensure the safety of the building for the community if we use self-healing concrete, which we can show based on the results before that self-healing concrete or bacterial concrete has higher strength than normal concrete. Next, benefits of self-healing concrete towards the industry. First, industry of conventional concrete will may be affected. Secondly, industry of biotech will increase due to the use of bacteria in concrete mixture, which is for self-healing concrete, we use bacillus. So it will affect the biotech in a good way, in biotech industry in a good way. Yes. Next, we move on to the benefits of self-healing concrete towards our environment. First, less carbon dioxide or CO2 produced from the cement factory because we use mainly bacteria, so there are less carbon dioxide produced. Secondly, environment air get cleaner than before due to the less carbon dioxide produced by cement factory. Next, we move on to the applications of self-healing concrete in Malaysia. First, self-healing concrete is suggested to be used towards the building in Malaysia. It will reduce the cost to maintain the building, long-term maintenance of buildings in Malaysia, which usually will be easily broke due to corrosion from rainfall. Self-healing concrete also could be applied in Malaysia because of the availability of biotechnologies in the country itself. We move on to the discussion of this presentation. Self-healing concrete is an innovative and promising technology that has the potential to revolutionize the construction industry and address some of the challenges associated with concrete deterioration. The concept of self-healing concrete involves integrating materials or mechanisms within the concrete mixture that can repair cracks and damage autonomously, thereby extending the lifespan of structures and reducing maintenance costs. Compared to regular concrete, self-healing concrete is better than normal concrete in all aspects. Self-healing concrete also has a great potential as a building material as it is able to heal its own defects without external human intervention. The mechanical of normal concrete lacks any built-in self-repair system. Concrete that has developed cracks may have less structural integrity and be more susceptible to corrosion and deterioration. Compared to normal concrete, self-healing concrete uses a variety of mechanisms to repair cracks. Use of encapsulated bacteria or other healing agents in the concrete mix is one typical technique. When cracks appear, water slips in and activates this substance, which then make calcium carbonate and seal the crack and stop any further damage. Lastly, we move on to the conclusion. The application of self-healing concrete in biological process may reduce the probability of concrete with the presence of defect. The process also may ensure that the concrete can be sustained for a long term, which will provide benefit in the future. Based on the research, it was found that the combination of the bacteria and the limestone product may produce a great impact to the concrete for them to heal themselves. In fact, the self-healing concrete can be applied to the building or any building in Malaysia. Hence, the problems of concrete defects, which is focused on the cracking of concrete, can be solved using the biological self-healing concrete method. That's all for the presentation of innovation in advanced material. Thank you very much for listening to our presentation and may we meet again.